This video lecture is meant to give you a tour of the periodic table to see how there are different ways that we can approach categorizing the elements on the periodic table, and just giving you some vocabulary terms so that you can talk intelligently about the periodic table. To do this, today you should have a handout from your classroom teacher, and you'll need colored pencils of 6 different colors. It doesn't really matter what colors they are, just choose 6 colors and come on back and we will introduce you to the periodic table. Objectives 3, 4, 5, and 6 are what we are covering in this lecture today, where Objective 3 says we're going to describe the differences between a group and a period on the periodic table. Now sometimes you'll hear us refer to the word family. Family is really the same thing as a group. So a period is, as you can see here in this slide, is a horizontal row in the periodic table. As we've already learned, there are 7 periods, which also happen to correspond to the 7 principal energy levels. So a period is a horizontal row. A group, or a family, is a vertical column of elements. Elements in the same group will have similar physical and chemical properties. That won't be true for the elements within a period. But the elements within a period, as we said before, will have electrons in the same principal energy level. Alright, you should have a periodic table that is ready to be color-coded to help us figure out where the metals are, the nonmetals, and the metalloids. This is objective number 4, where you will identify 3 broad classes of elements as metals, nonmetals, or metalloids. And you can see here that there is a separation line, looks like a staircase, starting to the left of boron and then marching down in a staircase-wise fashion all the way down here. The elements that touch this line have properties that are similar to both metals and metalloids. And we're going to color them one color. They're colored yellow here, but you can color them whatever color you choose. So metalloids, having properties of both metals and nonmetals, are boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine. The nonmetals are the elements to the right of the metalloids, from carbon, phosphorus, selenium, iodine, and radon, all the way up to this upper right corner. And notice hydrogen is also included as a nonmetal, even though it is over here on its own with the metals. Hydrogen is in this location because of its number of electrons, and that's very similar to the lithium and sodium and potassium, the other elements in that column. So you should have a second color coloring in the nonmetals, and a third color coloring in all the other elements, which are metals. There's another periodic table where you will be categorizing the elements based on their families. Families, or groups, are elements that have similar physical and chemical properties. And so now we're getting into objective number 5, which says we're going to identify where the following groups of elements are in the periodic table: alkali metals, alkaline earth metals, transition metals, intertransition metals, metalloids, halogens, and noble gases, which is off the screen for this recording. The first column you should color in is the alkali metals. This can be any particular color you choose. It does not have to be red, but the elements I have highlighted in red are the alkali metals. So go ahead and make sure you indicate that same color for your key up here. Just be sure not to include hydrogen in that grouping. The next group of elements are the alkaline earth metals, which is shown here by a bluish-gray color. This is column number 2, the alkaline earth metals. Column 3 through 12 on this periodic table are the transition metals, otherwise known as the D block. The halogens is the column almost all the way to the right, but the column starting with fluorine chlorine, bromine, iodine. That particular column right there is known as the halogens. And the column all the way to the right is known as the noble gases. You will not be responsible for knowing the other groups, which on this periodic table, this graphic, you can see we have them labeled as other metals and non-metals because you've already categorized those on a previous periodic table. So these are the element group family names that you will be responsible for locating on the periodic table. And if I were to ask you about a particular element and what category does it belong to, you should know, for example, that iron is not only a metal, but it is specifically a transition metal. So if I were to ask you about iodine, you should know that iodine is not only a nonmetal, it is specifically a halogen. One more group on this periodic table that I will have you identify is called the inner transition metals. This is the F block of the periodic table. These are also known as the rare earth elements. You might want to jot that down next to this term right here, inner transition elements, also known as rare earth elements. The last periodic table is to help you make the connection between placement of an element on the periodic table and the number of valence electrons. We've already learned about electron configurations, and you've already identified the first two columns on the periodic table as the S block, because those two columns are working on filling up the S sublevel of that particular energy level. And this block over here is known as the P block because these elements are working on filling up the P sublevel of that particular principal energy level. So first and foremost, objective number 6 says you're going to classify element groups based on the electron configuration and number of valence electrons. Okay. So to do that, you need to know that representative elements are the elements, any element found in the S or the P block are what we call representative elements. You might want to make note of that as a definition. Representative elements are the elements, any element found in the S and or P block. This is where you're going to look to determine the number of valence electrons an element has. Valence electrons are defined as the outermost S and P electrons found in the outermost principal energy level. So, for example, if we take a look at this first column, if we count the superscripts, we will see that if I were to ask you the question, how many valence electrons in that first column, any element in that first column will have one valence electron. So alkaline metals have one valence electron. The alkaline earth metals, the second column, will have two valence electrons. We can see that here in the superscript all the way down. Skipping the D block because D block electrons are not considered part of the valence. So we're going to ignore those for the moment. We go over here to the boron group. We'll see S2P1, S2P1. All the way down, all those elements have 3 valence electrons. The carbon family has 4 valence electrons. The nitrogen family, 5. The oxygen family has 6. The halogen family has 7 valence electrons, and the noble gases have 8 valence electrons. But you might be pausing at this moment because you look at helium and it just says 1s2. That's very different from neon, which has S2P6, or argon S2P6. So you can see where 8 electrons comes from there. But the helium has only 2 valence electrons, and that is the exception to this rule. Helium, because it is so small, only has room for 2 valence electrons. This concludes our video lecture on the tour of the periodic table. We'll see you in the classroom.